Okay, today I will talk about question 4 in the homework 6. And in that problem, we already know the xy have this relationship. It's Gaussian. So we will find the EY when x equals x. A normal way to solve this problem is we will find the PDF first. And the PDF can be written like this. And since we already know the x, y, and we can write these two very easily, but it's calculate a lot. Maybe not a lot, but calculate a little more. So today I will share a little trick to solve this problem much easier. First, I will introduce a new way to write the xy into another form. We will introduce two normal random variables, z1 and z2. Their means are 0 and the variance are 1. And we look at this, the mu x, mu y, and sigma x, sigma y can be choose the x into the sigma x cross the normal random variables and plus the mu x. It's make sure the mu x and sigma x match the relationship. And the same as y, we do the y into separate the n01 into the rho square and 1 minus rho square. Just because we will set a relationship between the x and y. These are not independent. And to write this form, replace the z1, z2 here, and we can get this. The only things we will question is, what's the row here? Is it this row equals to the row xy? And we will find these two row xy to find the problems. And the row xy equals covariance xy's over the sigma x, sigma y. And to solve the problems, we calculated it. Use the xy here, we can get sigma x z1's cross sigma y's rho z1's plus this. And here is one thing we should know is the EZ1 squares should be 1s because it's the variance here. And just because Z1 and Z2 are independent, so the EZ1, Z2 here should be 0. That means the covariance xy should be sigma x, sigma y plus cross rho. And compare these two formulas, we will get the rho xy is the rho. That means this relation here is a very successful relation to for these causes xy. Since we have this relationship, now we can do the problems much easier. To find this, we can write the xy into that form, and we replace the z1 here into x minus mu x. Just use this x minus mu x over the sigma x. So we can separate these two parts. In the first part, there's everything we know here, and look at the second part. The z2, these two we all know. And the EZ2x should be 0. Just because the Z2 is nothing about x. So EZ2 when x equals x is just the EZ2. And that's the mean of Z2 is 0. And the answer is so simple. It was just the first part of this. And it should be written like this. And that's the answer.